Well, thank you for staying to the last talk, and first I'd like to thank Mike very much for the invitation to do this. I've learned a lot over the course of the day on many aspects of what many of you are focused on across this really interesting space. I myself am not a nutritional biologist in any stretch of the imagination. I've worked in basic science most of my life, in biotech, pharma, and academia. And it was an amazing thing for me to come now to work for one of the largest food companies in the world, Nestle, in a very exciting program. What happened was back in September of last year, 27th, Nestle announced the formation of two new entities. One is called the Nestle Institute of Health Sciences, which I represent, and the other is the Nestle Health Science Company. And these are two independent entities within the Nestle structure that will focus in two different ways, and I'll tell you a little bit about that through my talk. Let's see, I guess I'll control that. So first, why do they do this? Well, many of you in the audience know that 1 out of 5 will be over 65 in 2020. It's really going to require healthcare systems to better adapt to the needs of the elderly, and this has been mentioned throughout the course of the day. 3 out of 5 will die from chronic diseases. So there needs to be even more emphasis on prevention and treatment of chronic diseases. That is, maintaining health as opposed to allowing people to get sick and then having to have the consequences of that to the healthcare system. 1 of 5 will be overweight or obese in 2020. So we need to treat increasing comorbidities such as cardiovascular disease and diabetes, as many of you also know. And in the US, 5 to 10 trillion will be spent on healthcare. So this is going to require radical ways in which to contain the costs and or increase available funding. So where is the Nestle Health Sciences Company? And in a supporting fashion, the Nestle Institute of Health Science is going to focus. The healthcare value drivers of 2020 will be person-centric, as we've all been talking about, information-heavy, that is, being able to connect all of this information on our health status with ways in which to keep our health instead of progressing towards disease. And it's going to be cost and healthcare driven. So first, person-customer centricity, patient empowerment. Again, we've been talking about that. Second, IT and technology achievements enabling business integration. Public authority and payers are going to be driving cost containment. Suppliers like pharma and medtech are consolidating, covering a broader and increased value chain. And then finally, traditional R&D pharma is not really delivering this return on investment, and that model is now starting to come apart and being reassessed. And we're going to have to integrate all of this into care delivery. So where is the Nestle Health Sciences Company going to focus? Now that's a pretty complicated slide up there, but it's really quite simple. It's, as people have been saying, there's the food industry, which Nestle has been playing in for over 100 years, and then there is the pharma industry, which of course pharma have been playing in for many hundreds of years. We're going to move in between food and pharma into an area that isn't really dietary supplements or functional food, but it's not pharma either. It's between that area, and it's really going to be in the area where you're trying to do primary or secondary prevention and possibly also disease modification. And so really what it's going to require to operate in that area is a much higher burden of scientific proof, both fundamental science backing the concept of a nutritional medicine, as well as very extensive clinical studies. And this type of activity is not traditionally what a food company would do. So it's more like a pharma company in that regard. The area that is between food and pharma, though, is really specific to that in the sense that we do not want to actually make pharma products. We're not interested in actually making a synthetic drug, a single molecule, to treat a specific disease. We're interested in actually working with nutritional compounds, compounds that exist normally in nature, that might be in the natural food chain, that will allow us to have a lower safety barrier, but not diminish the amount of science that we'll have to conduct. So, as I said, we'll be looking at the top scale where you're more healthy, or you might be just starting to progress or have a predisposition to get into a disease state, as opposed to treating patients that are already sick. So we'll be looking at primary, secondary prevention, and then maybe in long-term post-treatment. So what is the Nestle Institute going to do? What's its mission? Well, the Institute itself is really going to be built to create world-class excellence in biomedical research. So it's really going to do basic science in health and disease, genetics, metabolism, environment. Personalized science-based nutrition is where it's going in the future. The aspirations scientifically are regenerative, genomic, metabolomic platforms to model cellular function, develop cellular models that simulate genetic or metabolomic or physiologic characteristics of common chronic diseases, and to identify and discover nutritional intervention or biomarkers that modify or predict these molecular, cellular, and physiologic disease mechanisms. So it's really a basic science institute. So the basis of, in a very simplistic way, of chronic disease are a combination of relations between the environment, the metabolism, genetics, lifestyle, which feed into whether or not you remain healthy or progress towards disease. In a more scientifically approached fashion, we're going to develop a series of different core technologies within this institute. Just if you haven't heard, Nestle is dedicating 500 million Swiss franc to the formation and operation of this institute over the next 10 years. So we are going to bring in and set up a series of core platforms, many of which of you are working on, but all in one institute. These will be regenerative stem cell technology, cell-based models, metabolomics together with proteomics and lipidomics, functional genomics and deep sequencing and high-throughput screening. But all of this massive information that we're going to generate is going to need to be analyzed. And as many of you know, sorting through that kind of massive data is not easy to do. So integrated across this entire institute will be upwards of 50 to 100 different bioinformaticians, statisticians, and even mathematicians to comprehend this data and relate it in a systems biology approach. The focus areas in terms of disease are the obvious disease states: diabetes, obesity, cognitive decline, as they relate to healthy aging. And as many of you have also known, in a recent Nature expose on the big science at the table, all of these new technologies, all these omics technologies that are now available and have been highlighted by many of you in excellent talks today, are really now available and can be combined with various biological systems and physiological systems to try to reduce this data down to some function that makes sense with regard to the onset of disease or the maintenance of health. And I really like this statement, and we've talked about that today as well, that many researchers think that personalized nutrition must begin with a new suite of biomarkers, ones that measure health rather than disease. And as has been stated by many of you, it's not an easy thing to do. But what we are going to do is try to actually delve into these molecular processes in this institute to try to get the best scientific underpinning of these cellular mechanisms, these physiologic mechanisms, and relate those then to the development of new nutritional strategies and also products which have been highlighted throughout this conference. So an example would be if you take a control, for instance, a very reductionist example, a control pancreatic or hepatic or adipose cell as opposed to a diseased pancreatic, hepatic, or adipose cell, normal versus stress, young versus old, and you determine the omic platform, proteome, transcriptome, genome, etc. All this data is bioinformatically analyzed, and then disease phenotypes or pathways and biomarkers are determined, possibly allowing you to set up a model that you can test over and over again in the laboratory and use to screen not only pharmaceutical compounds but natural product library compounds. So if you kind of look at it in a different way, if you looked at a disease progression such as metabolic syndrome, for example, where you have behavior and diet and genes all interacting to cause obesity, which then leads to insulin resistance, hypertension, chronic inflammation, dyslipidemia, and finally diabetes, kidney disease, stroke, etc. This is the progression all the way down this path. What the Nestle Health Sciences company will be doing is addressing the behavior, the diet, taking into account the genes to reduce weight, to normalize the abnormalities while offering targeted products and ways in which to measure this progression and to stabilize or treat the conditions eventually. The research at the Nestle Institute of Health Sciences is really going to be, much more basic, and you can see examples here: functional genomics, metabolomics, lifestyle and e-medicine to segment populations, human adipocyte cellular switching and modeling, adipose and muscle signaling, mitochondrial function and intestinal models, and human pancreatic islet functional models. So these are the types of systems that will be set up at the Institute to try to actually add a fundamental scientific underpinning to what the Nestle Health Sciences company will eventually be either buying in or licensing in to develop as the next products in this medically based nutritional area. So if you put it all together at the Institute, we're going to be using these platforms surrounded by these key focus areas, these chronic disease, these complex chronic disease areas, to develop models for molecular processes, to identify epigenetic and metabolomic signatures, and to apply these to high-throughput screening to discover compound and nutritional activities. To help the Nestle Health Sciences company as well as greater Nestle develop these more personalized, and I agree with a focused personalization, a targeted audience of people to focus on first, develop nutritional strategies and products and clinical programs to address these issues. So if you kind of simplify it once more, it's an integration of genomics, metabolism, nutrition, and environment and lifestyle, which is nutrigenomics, what many people have been trying to do, but we're going to try to do this all in one institute. Of course, the institute will be very collaborative, which I'll talk about in just a second. But the Nestle Institute of Health Science will do the basic biomedical science. The Nestle Health Sciences company will produce the products and solutions to go towards personalized science-based nutrition. So where is this going to be? It's going to be on the EPFL campus in Lausanne, Switzerland. Quite a beautiful place. And about 14 years ago when I first came here, I fell in love with the area, and I happened to, with my wife, buy a piece of land and build a house there. And have been coming back after my 4-year stint with a biotechnology company in Lausanne ever since. And then I was about to move to New York, and someone said, hey, wouldn't you want to come back here and build an institute? It happens to be right across the street from where you live. So that's what happened. And so basically there are two buildings you can see here in this Innovation Square. It's part of the EPFL campus, G and H. The H will be the full institute, but the G will be a starting set of space to set up much more collaborative-based laboratories. These are what the buildings look like now. The G building is at least the shell completed, and we're starting to outfit, and hopefully we'll be occupying in November, October timeframe of this year the first laboratories. Within this space, we're going to build the functional genomics lab, which is going to have up to 20, if you might say, high-seq 2000 sequencers, if you know what those are from Illumina, but essentially the capability of doing sequencing at that level. So it's going to be probably the second largest functional genomics center in Europe. It'll be in the basement of this building G. Together we'll build cellular modeling labs on the next floor and more DNA and robotic isolation labs on the top floor, as well as a small proteomics metabolomics unit. In the H building, this will all be expanded. So for the future, in 2011, 2012, we're really going to be building these core platforms, basic science strategies, and by 2015, as Mike mentioned earlier, publishing high-impact science in this space. The aim is really to publish in top-rated journals, to come to meetings such as these and interact with the top scientists in the world in this space, and to basically translate these basic biomedical outputs out of the Institute to the greater Nestle, specifically the group Nestle Health Sciences Company. And then in 2020, hopefully we'll be starting to implement that. I was just at a functional genome meeting in San Diego, California, where they were celebrating the 10-year anniversary of the discovery of the human genome. In fact, the first contiguous sequence that was put together of the human genome. So the 10-year anniversary was being celebrated by Craig Ventnor and all of his collaborators. And I think there was a recent issue in Science and Nature talking about what the next 10 years would be like, or going to be providing to you. And yes, the genome can be sequenced now for as little as $1,000. And yes, in 3 years' time, as Ben was mentioning, people will be able to walk in and get their whole genome done probably in a day. Where it takes about a week now. So it's really moving quite rapidly. But still, the amount of knowledge that people have about our genome is still infinitesimal when it comes to reducing it to function and understanding how a particular SNP really results in a functional effect that results in either your health being bad or good. So this is basically what they say is that we're now at the starting line, just like I think we are now at the starting line in this field as well, in terms of applying this kind of scientific horsepower to it. So thank you very much, and I'm open to any questions.